Hey, how's it going? It's Steve Williams from RadicalStrengthCoach.com. This first video I've got to share with you is all about insulin. Now, I just want to say at this point that I'm not a doctor, I'm not a biochemist, and I'm not a hormone expert, but you can take this information to the bank because the guy I got it from is a doctor, is a biochemist, and he is a hormone expert. His name's Dr. Brian Walsh. If you want to look at this stuff more deeply, just look him up on Google. So let's get straight on with it. Let's first talk about the role of insulin. So this is the digestive system, this is the liver, this is the stomach, this here is the small intestine, and this long slender organ in the middle here is the pancreas. This is where insulin is released from. Now insulin's a peptide hormone and it's made of protein, and the main job of insulin is to regulate blood sugar. So let's take a look at what happens when we eat a food. So we eat a food, it comes down into the stomach, and after a while it passes into the small intestine. The pancreas senses this and it releases digestive enzymes because everything we eat has to be broken down into its smallest form. So glucose, amino acids, vitamins and minerals all go into the liver first before they go into the bloodstream. So in the case of glucose, it goes into the liver and then it goes into the bloodstream, and when it reaches the pancreas, insulin's released. So that's the role of insulin. Now let's take a look at the physiology of insulin and all the different tissues it acts on. So first of all, it acts on the liver and it stores glucose as glycogen. Now at the same time, a process called gluconeogenesis is taking place, and all this really means is glucose has stopped being released by the liver, and this makes sense because if you've got high blood sugar, you don't want any more being released into the system. The second place it acts on is the muscle tissues. Again, glucose is stored as glycogen, and this can be used as fuel when the muscles are working or when you're exercising. The third place that insulin acts on is on the fat tissues, and this time glucose is stored as triglycerides. So at the same time, again, fat breakdown is stopped, as in the case of the liver, because we don't want any more blood sugar running around the body. So you'll see here I've got an arrow pointing to the hormone leptin. Leptin's known as the satiety hormone. When you eat a food and we get that satisfied feeling after eating, that's leptin doing its job. The fat tissues release leptin, which then travels to the brain, which tells the brain to stop eating because we've got enough food right now. So that's the physiology of insulin and all the different places that it acts on. Now let's take a look at how insulin gets glucose into the cell. So now let's take a look at the physiology of insulin and how insulin gets glucose into the cell. So this square box here, this is the cell. This is the nucleus of the cell. This here is the bloodstream. These little red dots here are glucose molecules, and this I stands for insulin. So let's take a look at how it works. We eat a food, blood sugar goes up, glucose is released. Insulin attaches onto the receptor cell, sends a message to the GLUT4 vesicles, which are these little things inside the cell. They've got these straws on them. When the GLUT4 vesicle gets the message, it comes to the surface of the cell, inserts its straws in, and allows glucose into the cell. This is what happens in normal physiology. As you can see, I've drawn two GLUT4 vesicles. The reason for this is this second one here doesn't need insulin to perform its function. This is what you call an exercise-induced GLUT4 vesicle. Exercise is a stress on the body, and we need glucose to perform whatever function it is we're asking the body to do. So when we do intense exercise, this GLUT4 vesicle senses it, moves to the surface, and inserts its straws through the biolipid membrane, and again allows glucose into the cell. It's an amazing system. So what can go wrong? Well, there's a few things that can go wrong. First of all, there can be a problem in the pancreas, and this means that the pancreas isn't producing insulin. Now, this usually happens prior to age 30, and it's called type 1 diabetes. The second problem that can happen, which is very common, is that these receptor cells begin to downregulate. It's a condition called insulin resistance. When we have too much of a hormone floating around the body, the receptor cells will begin to downregulate, so insulin isn't allowed to act on the nucleus of the cell. A third thing that can go wrong is that there's a multitude of things that can break down inside the cell, which we won't go into. So that's the physiology of insulin and how insulin gets glucose into the cell. Now let's take a look at all the different disease processes that insulin acts on and how it impacts fat loss, etc. So the first thing insulin does is it raises blood pressure, and obviously this causes a cardiovascular risk. The second thing it does is it raises cholesterol. Now, this is a basic biochemical pathway, which means it's easy to fix. Now, the main reason that a person will have high cholesterol is because of high insulin. So these two factors here, as I said, prove that make it a cardiovascular risk. So another thing that insulin does is it increases a pro-inflammatory hormone called interleukin-6. Interleukin-6 is known to increase cortisol, which, as you're going to find out in the next video, cortisol's main purpose is to raise blood sugar. And if you've got raised blood sugar, you've got high insulin. So now you've got a vicious circle. So the next thing insulin does is it increases the risk of cancer. And the reason being is because insulin's an anabolic hormone. It makes things grow. So anybody who's susceptible or is suffering from cancer really needs to get insulin sorted out. So it also causes leptin resistance. If you've got continually high levels of insulin, you'll have continually high levels of leptin. And as I said earlier, when you have high levels of a hormone running around the body, the receptor cells on the surface of the cell will downregulate. And this will mean you've got lots of leptin floating around, but it's not getting the message to where it needs to go. So a person will just carry on eating. Insulin's also shown to cause mood disorders, and this can undo any fat loss, nutrition or exercise program just due to lack of motivation. Another thing insulin does in men is it lowers testosterone and raises estrogen. It actually does the opposite in women. It raises testosterone and lowers estrogen. Now, these two factors will cause a decrease in liver function, and they'll manifest as an inability to clear out hormones and an inability to detoxify. So I've given you a lot to think about there. So now let's move on to the problem. The problem is we need a steady supply of glucose for the brain and the main organs, but too much glucose is toxic to the body. It's toxic to the eyes, the brain, the nervous system, and the kidneys. So what's the solution? The solution is to stay away from sugars, refined and excessive carbohydrates, and do this. Eat 4 to 6 smaller meals consisting of protein, fat, and non-starchy vegetables. And I'll give you an example. This is an example out of my life. Breakfast, bacon, egg, mushrooms, fried in butter. Snack, 2 boiled eggs or a protein shake. Lunch, a ham salad. I always try to eat a certain amount of raw food daily because it saves on your own enzyme supply. Snack, 2 slices of meat or a protein shake. Dinner, steak, asparagus, fried in butter. Scrambled eggs, fried in butter. Really simple stuff. This is just an example of how I live my life. Now, what I haven't mentioned here is carbohydrates and how that all relates to building muscle and exercise, and that's for another video. So I've given you a lot to think about with the insulin problem, and hopefully I've given you a solution as well. So hopefully you'll tune in to the next video, which is all about the stress hormone, cortisol. So that's Steve Williams from Radical Strength Coach. Thanks very much for your time.